Hello friends, look at this fascinating exercise we have here. As always, you can solve it in your notebook and leave me your answer in the comments. The exercise tells us to find the area of the rectangle within the square, that is, this shaded part. But it's also giving us data that this is a square and well, this is a rectangle obviously. So what are we going to do first? We're going to erase this shaded part because we're going to make some lines here. We'll also jot this down. We're going to find the radius of this circle and of this circle here. So we know that the area of a circle equals pi by radius squared, right? Now let's clear up having that the side of the circle, the area of the circle over P, it's going to be equal square of the radius, and then we apply the square root to both sides of the equation. This 2 simplifies with the root indexes 2 and we get that r equals, let's keep the r on the left side, r equals the square root of the circle's area over pi. Fantastic, we have the formula to find the radius. Here we don't add plus or minus because we are calculating distances and obviously we only need it on the positive side. So we have that the radius will be equal in the case of the big circle to the square root of the circle's area, which is 8p. Regarding the speedy here, very well, we simplify p and with pi. And we find that the radius of the large circle is the square root of 8. Fantastic. Around here we can leave written this square root of 8. Look at it this way. By 4 by 2 gives us this 8 here. We can take the square root of 4, which is exact, and we get 2. And inside the root we get square root of 2. Then the square root of 8 equals 2 times the square root of 2. Phenomenal. Let's put it here. 2 square root of 2, and we're about to see why we don't leave it as square root of 8. We can erase this from here because we know it can be transformed, that square root of 8 into 2 square roots of 2. Now we are going to determine the radius of the small circle. Then just change here for a 2. Then we have 2p on u. Very well, this is the area of the big circle. It doesn't get removed from the small circle. It gets removed or simplified, this pi with this pi. And I find that the radius of the small circle is the square root of 2. Phenomenal. We have already found the 2 radii, the radius of the large circle and the radius of the small circle. We can erase this part here, which are the areas, and the center point of each circle will appear. Now let's draw a line from the center point of the small circle all the way down to the tangential point of the circle with the base of the squares. So this one here has the radius, so it's going to be square root of 2. Very well. We can also draw a line from here to the center of the circle, and that is also the SQRT of 2. And here we can also trace, we can follow this line. Notice we're going to trace it up to here. Very good. Up to here, this part from here to here is also square root of 2. And this part here, we still don't know how much it is. This part isn't important to include, but it's known that this is the radius, right? Now what are we going to do? If we have the square root of 2 here, we're also going to have the square root of 2 down here. And if this is the square root of 2, this part here is also the square root of 2. And this one here is also the square root of 2. Only up to here, from here to there. Here, we can also draw a line from this center point of the circle to the other center point of the circle like this. And then we will draw a completely vertical line from this center point of the circle parallel to this one here. This way, and it will form for us
a rigid
rectangle
triangle.
here. There's 90 degrees. And now we're going to see over here, this part here is the radius. So it's square root of 2. And the radius of the large one is 2 times the square root of 2. Now you see why we changed it to this square root of 8. Because now we can add. To be able to add, they have to have The roots must have the same radicand. Now we can add this square root of 2 plus these two square roots of 2, and that gives me a total 3 times the square root of 2. That's going to be the hypotenuse of this little right triangle we have here. If we continue this line, which is a line that divides the square into 2 equal parts, pay attention, so far it's a diagonal line. We can also extend it here. Let's erase, let's do it right. So we can continue this line, pretend it's a straight line. So how can we do this part here? We can say that this big triangle that's here in blue, it's equal to the small triangle we have here. It's similar. How do we know it's similar? Because this angle is equal to this angle here. And this angle is 90. And here we also have 90. And this angle here is also equal to this angle over here. Because, well, this line here is parallel to this one, and this line here is parallel to the one below. That's why these angles must be equal, and therefore the triangles, the small triangle with the big triangle, are similar. Now here is the trick to solving this exercise. Let's draw a notable triangle over here. Pay attention, this over here is a notable triangle, and it's also a right angle. So here we have side 1, and here we will have square root of 2, because the hypotenuse is the sum of the two sides squared. 1 squared is 1 plus 1 squared is 1, so 1 plus 1 is 2 inside the root, right? So we have this notable triangle that looks a lot like this over here. What's the difference with having a 3 here? But we can multiply the hypotenuse by 3, and then we have what we have here. But we also need to multiply all its sides by 3.
Thank you.
Multiply here by 3 and here as well. So this side here will be 1 times 3, which gives us 3. And this part here is going to be 3, right? And we know then that this is right because the triangles are alike. This part here, which is the side of the square, should be equal to this side here because it's a square. Its sides must be equal. And this over here should also be equal since their sides are equal, right? So we can say that we have this triangle and we already have a lot of the data we need. Now this tangential point down to here, to this point here, we know how much it is. It's the radius of the big circle we had mentioned. 2 times the square root of 2. Fantastic. And down here we have this little part right here, which we know is square root of 2. And we found the side of the square since all its sides are equal. So then we found its side on all its sides. No, then what do we have to do? We have to add up these little parts here. We needed to add up these two. Then we're going to put here the side of the square will be equal to 2 square root of 2 plus 3 and again plus 3 and more square root of 2. Phenomenal. So we have that the side of the square is equal 2 times the square root of 2 plus the square root of 2 equals 3 times the square root of 2. But first let's place this 3. Let's put 3. Even more so, if we add this one to this one, it gives us 3 square root of 2. Phenomenal. We found the side of the king of the square. Sorry. So this side here from here to here, look. 3 plus 3 square root of 2. From here to here also measures 3 plus 3 square root of 2. Fantastic. So now we can determine, look at this part here is, what is the height of the rectangle? How do we do it?
Let's go for it.
Here we're going to have the rectangle's height will be equal all this part here. Although it measures 3 plus 3 times the square root of 2. Now this over here is all of this part here. And what are we going to subtract? We're going to subtract this distance from here. This distance here is the same as the diameter of the circle. The circle's diameter is not adding this with the 3 because this 3 spans a distance from here down to here. So the diameter is twice the radius. So twice the radius would be 4 square root of 2, then minus 4. Square root of 2, awesome. We have 2 in the height of the rectangle is 3. And over here we have 3 times the square root of 2. Minus 4 times the square root of 2 leaves us. There's 1 time the square root of the phenomenal. We have here the height, this little part. So 3 minus square root of 2 spectacular. Now let's find the base of this rectangle, this part here. We'll find it in the same way too. We're going to note it with the letter B. So all this part should measure the same as this part here. Because it is a square, it has all its sides equal. So we'll also have 3 times 3 plus 3 square root of 2 less than what we're going to subtract from this here. We're going to subtract these 2 parts here. If this part here is square root of 2, down here it's going to be square root of 2 as well.
This
here, part of here are adding these two
things, right?
Then we have 2 times square root of 2. That's the distance from here to there that we will subtract from this here, no? So 2 square root of 2, we then have that the base of the rectangle is equal. See you at 3. 3 times the square root of 2 minus 2 times the square root of 2 is once the square root of 2. Great, and now yes, we can find the shaded area. Fantastic, we have that the shaded area equals, since we have a rectangle, let's return the color.
It is
for
base.
height check. This base is 3 plus square root of 2 base by height. Then we have a base by height. We see that the shaded area is equal. What is the base on the base? Well, it is 3 plus square root of 2. What is the height? The height is 3 minus square root of 2. And this is very well known. This is a difference of squares which we can write in the following way. Look, the first term squared. Subtracting the square of the second term has the square root of 2 also squared, right? Notice this here is the same as writing this over here, right? It's a difference of squares that is written in this form by factoring it. Then we have that the shaded area is equal to 3 squared, which is 9 minus the square root of 2 squared simplifies to this 2 with the root index and just becomes 2. Not less, we have to give and amaze this 9 minus 2. That's 7 square units. Fantastic. We've already found the solution to our exercise in an impressive way. This exercise was very interesting. Let me know in the comments if you liked the video. Don't forget to subscribe and hit like so you don't miss the next challenge. We'll meet at another time. Bye bye.